Okay, this one is about solving equations that actually have logs in them. So again, reminder of the rules. And what we're going to be doing now is putting the pieces together. So if I have two logs of the same base added together, it becomes log of that same base of the product. Division becomes, subtraction of exponents becomes division. And again, I want to think about raising to a power, how I work this part out. But the other part is also knowing how to evaluate logs. So if you have log base 3 of 81, you need to say in your head 3 raised to what equals 81. Well, that's 3 to the 4th equals 81. So log base 3 of 81 is equal to 4 because 3 to the 4th equals 81. Log base 2 of 1/8. So I think 2 raised to what equals 1/8? Well, that's 2 to the negative 3rd. Therefore, log base 2 of 1/8 is equal to negative 3. Log base 5 of square root of 5. I got to think 5 raised to what equals square root of 5? Well, that's 5 to the 1/2. So therefore, log base 5 of square root of 5 equals 1/2. That's because 5 to the 1/2 is equal to the square root of 5. So we need to use this periodically when we're solving problems. So we're going to put together using our rules that we have for logs. I've got a subtraction problem. So I'm going to rewrite this as log base 3 of x plus 1 over x minus 1 equals 2. Now, I'm going to convert to get rid of the log. I'm going to change to exponent form. So we got 3 squared is equal to x plus 1 over x minus 1. 3 squared equals 9. Now it's just an algebra problem. So I'll cross multiply. So I get 9x minus 9. I'll subtract x from both sides, add 9, divide by 8, and I get 5/4. Now it's a good idea, but you need to check this to make sure I don't take logs of negatives. Plug in 5/4 in the original equation and make sure you don't get a log of a negative. Well, the one I have to worry about is right here. 5/4 minus 1 equals 1/4. That's greater than 0, so I'm okay. Okay, so let's take a look at this one. So again, I'm using my log rules. This time we have addition. So it's going to be log base 7 of x minus 3 times x plus 5. I've got log base 7 over here. I can take the 2 and move it up. Now when I get one log equaling another log of the same base, I can drop the logs and just look at what's left over. So I've got x minus 3 times x plus 5 equals x squared. If I multiply this out, I'll get x squared plus 2x minus 15. Well, the x squareds will cancel each other out. Subtract x squared from both sides. I can add 15, divide by 2, and I get 15/2. So 15/2 or 7.5. Make sure when I plug in 7.5, I don't take logs of negatives. So I keep mentioning about making sure I don't take logs of negatives. So be careful, because sometimes you may get answers that are not part of the solution. So let's take a look at this one. We have log base 5 of x plus 1 plus log base 5 of x equals log base 5 of 12. Well, it's all log base 5, so I'm going to get this side as a log base 5 equaling log base 5 of the other side. So again, addition of logs. So that becomes a product. Log base 5 of x times x plus 1 equals log base 5 of 12. Well, now I've got log base 5 equaling log base 5. I can drop my logs, and I get x squared plus x is equal to 12. Got a quadratic, so subtract 12. Factor it. I get x plus 4 times x minus 3. So I get x equaling negative 4 and x equals 3. But I've got to take and make sure I'm not doing anything illegal. If I plug in negative 4 here, I get log base 5 of negative 3. I can't take logs of negatives. Log of base 5 of negative 4. I can't take logs of negatives. You actually get complex numbers, but they're really complex. Well, complex numbers are complex, but it involves something that's well beyond the course that we're doing right now. So right now, we're basically going to eliminate negative logs of negatives. So I'm going to cross that guy off. That means my answer is going to be x equals 3. So we're just going to work with real numbers and not complex numbers with logs. Okay, now, well, look at this. I've got base 3, base 5, base 2. I can't combine these because they're not the same base, but I can evaluate them. So I say log base 5 of 25. So I go 5 raised to what equals 25? Oh yeah, it's 5 squared, so therefore this is 2. Log base 2 of 32, so 2 raised to what equals 32? Oh yeah, that's 2 to the 5th, so that becomes 5. So that means, let me erase this. We have log base 3 of 2x plus 7 plus 2 equals 5. I'll subtract 2 from both sides. Now to get rid of the log, I do 3 raised to the 3rd, that's 27. Subtract 7 from both sides, divide by 2, and I get x equals 10.